Okay, this video is about series circuits. So I'm going to draw a series circuit. Alright, let's give it some values. 9 volts, 3 ohms, 10 ohms, and 6 ohms. We'll call this resistor 1, resistor 2, and resistor 3. Okay, so this is called a series circuit for this reason. The current has only one way to go. It has to go through every resistor. There's no additional branches. Everything happens one after the other. Everything is in series. There's no alternate path. That's what makes something series. Here are some general rules of a series circuit. Voltage applied is equal to the voltage drop across all of the resistors, however that may be. Hint, hint, from a different video, this is Kirchhoff's second law. Kirchhoff number 2. The current in series is the same everywhere. And that makes sense because there's nowhere else for the current to go. It has to go through every resistor, so it's going to be the same at every point. And then the equivalent resistance, or the total resistance, well, that's nice because you just add them all up. Those are the 3 basic rules for something in series. So, really what I have, I could rewrite this circuit with one resistor because I could just add up all of these resistances. Because that's the rules for a series circuit. So 3 plus 10 plus 6, that's the same as 19 ohms. So it's really like I have this circuit here. It's really no different. So if I want to find out my current, which so far is the only thing I don't know, I have to bring back in another law, Ohm's law, V equals IR. So if I know my voltage is 9, and I know my resistance is 19, I can divide by 19 and find that my current is 0.4736842211. Now you can round. I always go out to 4 digits. So my current is 0.4737. So that means at any point in this, because it's in series, my current will be 0.4737. So what I usually ask is for the applied voltage, 9 volts, the equivalent resistance, 19 ohms, and the total current, 0.4737. But I also ask for the voltage and current across each resistor. And this can be done by just creating little miniature Ohm's laws all throughout these. And so if we look at our rules, the only thing that we know is constant is my current and my resistance. I'm not changing my resistors here. That's staying 3 ohms, that's staying 10 ohms, that's staying 6 ohms. Not changing those. And my current is constant because, well, in series, current is always constant. So I'm going to calculate the voltage drops across all these, and according to Kirchhoff's law, all those voltages better add up to what my battery is. So let's do that. I know that my current is the same, so I can just make the current across each resistor 0.4737. So if I know my resistance and I know my current at each resistor, I can use Ohm's law to figure out the voltage drop. So let's look at the first resistor, R1. I have 0.4737 amps of current going through there, times the resistance, 3 ohms, gives me 1.4211 volts. We keep going. I have 0.4737 amps of current going through the 10 ohm resistor. So if I multiply them, it's 4.7 737. Again, volts. And then lastly, I have that 0.4737 going through my 6 ohm resistor, and that's 2.8422 volts. If I add up all of these voltage drops here, hopefully I get really darn close to 9. So 2.8422 plus 4.737 plus 1.4211, I get 9.0003, 9 volts. So I obey Kirchhoff's law. I find my voltage and my current across each resistor, and all is good in this series circuit. If you have any questions, be sure to ask.